When considering ventilation slots in electrical equipment control boxes, it's important to adhere to established safety standards and guidelines. The National Electrical Code, specifically Article 430.3 regarding other equipment, addresses ventilation openings. This section stipulates that for equipment like air compressors, vacuum cleaners, and exhaust fans, ventilation openings with screens or louvers must be provided in the enclosure. The purpose of these openings is to prevent overheating of the equipment. In addition to the NEC, NFPA 79, which is the electrical standard for industrial machinery, provides further guidance. Section 11.21 outlines opening requirements for ventilation slots and louvers. This section emphasizes that openings should be designed and located to prevent the equipment from becoming a hazard. Firstly, the design must prevent exposing live parts to personnel. Secondly, it must prevent allowing expelled solid or liquid particles from striking personnel. Thirdly, the design should avoid providing an opening large enough to allow a person to insert any part of their body, other than hands, when the equipment is in operation. Furthermore, NFPA 79 Section 11.21b states that openings in enclosures of electrical equipment should be positioned to minimize the risk of injury from arc flashes or explosions. Beyond the NEC and NFPA 79, OSHA Standard 1926.414 in UON also applies. This OSHA standard requires that electrical equipment be installed so as to minimize the likelihood of access to live parts. ANSI/UL 500AD, which covers industrial control panels, also contains relevant requirements. It states that ventilation openings must be designed to prevent the entry of dust, dirt, or other foreign objects that could interfere with the operation of the equipment. It's important to note that the specific requirements for ventilation slot placement and protection can vary. These variations depend on factors such as the size of the equipment, the specific application, and the potential hazards involved. Therefore, it is always recommended to consult with the equipment manufacturer or a qualified electrical engineer to determine the appropriate requirements for the specific application. In summary, when designing and installing ventilation slots in electrical equipment control boxes, one must consider several factors to ensure safety and compliance. Firstly, prevention of overheating is a primary concern addressed by providing adequate ventilation openings. Secondly, protection of personnel from hazards such as exposure to live parts, expelled particles, arc flashes, and explosions is essential. Thirdly, prevention of foreign object entry is necessary to maintain proper equipment operation. By carefully considering these factors and consulting relevant standards and experts, it is possible to create safe and effective ventilation systems for electrical equipment control boxes. Further consideration should be made to ensure that the placement of ventilation slots does not compromise the enclosure's protection rating against environmental factors such as water, dust, and corrosion. Depending on the environment where the equipment is installed, additional measures such as filters or specialized louvers may be necessary to maintain the integrity of the enclosure. It is also important to consider the airflow patterns within the enclosure to ensure that the ventilation slots are effectively dissipating heat. The size, number, and placement of the slot should be carefully calculated to provide adequate airflow without creating hotspots or compromising the structural integrity of the enclosure. In addition to the above considerations, it is crucial to establish a regular maintenance schedule for the ventilation slots. Over time, these slots can become clogged with dust, dirt, or other debris, which can reduce their effectiveness and potentially lead to overheating. Regular cleaning and inspection of the slots can help to ensure that they are functioning properly and that the equipment is operating safely. Finally, it is important to remember that ventilation slots are just one component of a comprehensive electrical safety program. A well-designed and properly maintained electrical system should also include other safety measures such as proper grounding, overcurrent protection, and regular inspections. By taking a holistic approach to electrical safety, it is possible to minimize the risk of accidents and injuries and to ensure the safe and reliable operation of electrical equipment. Remember that codes and standards such as the NEC, NFPA 79, OSHA 1926.414 in EURN and ANSI/UL 508 are updated regularly. So, it is critical to stay informed about the latest revisions and interpretations to ensure ongoing compliance. Consulting with qualified professionals and participating in industry training programs can help you stay up to date on the latest electrical safety practices. Also, consider the material used for the ventilation slots or louvers. It should be compatible with the enclosure material to prevent galvanic corrosion. For example, using aluminum louvers on a steel enclosure in a corrosive environment can lead to premature failure. Proper material selection is essential for long-term reliability. Furthermore, assess the potential for condensation within the enclosure. If condensation is likely, consider adding drain holes or using desiccant packs to prevent moisture buildup, which can damage electrical components. The placement of ventilation slots should also take into account the location of sensitive components within the enclosure. Avoid placing slots directly above or below components that are particularly vulnerable to dust, moisture, or other contaminants. Strategic placement can help to minimize the risk of damage and ensure reliable operation. Consider the accessibility of the ventilation slots for maintenance and cleaning. Slots that are difficult to reach may be neglected, leading to reduced airflow and potential overheating. Design the enclosure with easy access to the slots for routine maintenance. Noise levels can also be affected by ventilation slots, especially if the equipment generates significant noise. Consider using sound dampening materials or designing the slots to minimize noise transmission. This is particularly important in noise-sensitive environments. When selecting louvers or screens for ventilation slots, consider the pressure drop across the opening. A high pressure drop can reduce airflow and increase energy consumption. Choose louvers or screens that offer a good balance between airflow and protection against foreign objects. Ensure that the ventilation slots do not create sharp edges or protrusions that could pose a safety hazard to personnel. Smooth edges and rounded corners can help to prevent accidental cuts or scrapes. Clearly label the enclosure with appropriate warnings and safety information, including the location of ventilation slots and any potential hazards associated with them. Proper labeling can help to prevent accidents and ensure that personnel are aware of potential risks. Document the design and installation of the ventilation slots, including the size, location, materials, and any special considerations. This documentation can be valuable for future maintenance and troubleshooting. If the equipment is used in a hazardous location, such as an area with explosive gases or dust, ensure that the ventilation slots are designed to meet the requirements of the relevant hazardous location standards, such as those outlined in the NEC Article 500 through 516. Hazardous location standards often require specialized enclosures and ventilation systems to prevent explosions and fires. If the equipment is subject to vibration, ensure that the ventilation slots are designed to withstand the vibration without becoming loose or damaged. Vibration can cause the slots to rattle, creating noise and potentially compromising their effectiveness. Consider using vibration-resistant materials or designs. If the equipment is used in a marine environment, ensure that the ventilation slots are designed to resist corrosion from salt water and other marine elements. Marine environments can be particularly harsh on electrical equipment, so it is important to use corrosion-resistant materials and designs. If the equipment is used in a food processing environment, ensure that the ventilation slots are designed to meet the requirements of the relevant food safety standards. Food processing environments often require special enclosures and ventilation systems to prevent contamination of food products. Consider the potential for insects or other pests to enter the enclosure through the ventilation slots. If pests are a concern, consider using screens or other barriers to prevent them from entering. Ensure that the ventilation slots do not interfere with the operation of any other equipment or systems in the vicinity. For example, avoid placing slots directly above or below sensitive electronic equipment. If the equipment is portable, ensure that the ventilation slots are protected from damage during transport. Consider using covers or other protective measures to prevent the slots from being broken or bent. Regularly inspect the ventilation slots for signs of damage or deterioration. If any damage is found, repair or replace the slots immediately to prevent further problems. Keep a record of all maintenance and repairs performed in the ventilation slots. This record can be helpful for tracking the performance of the slots and identifying potential problems early on. Consult with a qualified electrical engineer or other expert to ensure that the ventilation slots are designed and installed in accordance with all applicable codes and standards. A qualified expert can help you to identify potential hazards and to develop a safe and effective ventilation system. Also, verify that the chosen ventilation strategy doesn't negatively impact the ingress protection, rating or NEMA rating of the enclosure. Maintaining the enclosure's original protection level against dust and water ingress is vital for the longevity and safe operation of the enclosed electrical components. Conduct a thermal analysis to ensure that the ventilation design effectively dissipates heat and prevents hotspots within the enclosure. Thermal analysis can help identify areas where airflow may be restricted or where heat is concentrated, allowing for design adjustments to optimize cooling. Consider using computational fluid dynamics (CFD) simulations to model airflow patterns within the enclosure and optimize the placement and size of ventilation slots. CFD simulations can provide valuable insights into the effectiveness of different ventilation designs. Explore the use of active cooling solutions, such as fans or thermoelectric coolers, if passive ventilation alone is insufficient to maintain safe operating temperatures. Active cooling can provide more effective heat dissipation, but it also adds complexity and cost to the system. Ensure that any active cooling components are properly integrated and controlled to prevent overheating or other problems. Implement a monitoring system to track the temperature and humidity within the enclosure and alert personnel if conditions exceed safe limits. Monitoring systems can provide early warnings of potential problems, allowing for corrective action to be taken before damage occurs. Develop a contingency plan to address potential ventilation failures, such as clogged slots or fan malfunctions. The plan should include procedures for identifying the problem, isolating the affected equipment, and restoring ventilation as quickly as possible. Consider the aesthetic impact of the ventilation slots and the overall appearance of the equipment. While functionality is the primary concern, it is possible to design slots that are both effective and visually appealing. Coordinate the design of the ventilation slots with the overall design of the equipment to ensure a cohesive and professional look. If the equipment is used in a public area, consider the potential for vandalism or tampering with the ventilation slots. Implement security measures, such as tamper-resistant screws or covers, to prevent unauthorized access or damage. Clearly communicate the importance of proper ventilation to all personnel who operate or maintain the equipment. Training and education can help to ensure that personnel understand the risks associated with inadequate ventilation and the importance of keeping the slots clean and unobstructed. Establish a regular audit program to verify that the ventilation system is functioning properly and that all applicable codes and standards are being followed. Audits can help to identify potential problems and ensure that corrective action is taken promptly. Stay informed about the latest advancements in ventilation technology and consider incorporating new technologies into your designs as appropriate. New technologies, such as smart ventilation systems and advanced cooling materials, can offer significant improvements in performance and efficiency. When replacing or upgrading ventilation slots, ensure that the new slots are compatible with the existing equipment and that they meet all applicable codes and standards. Using incompatible or non-compliant slots can compromise the safety and performance of the equipment. Maintain detailed records of all ventilation-related activities, including design specifications, installation procedures, maintenance records, and audit reports. These records can be valuable for future troubleshooting and for demonstrating compliance with regulatory requirements. Regularly review and update your ventilation practices to ensure that they are aligned with the latest industry best practices and regulatory requirements. Continuous improvement is essential for maintaining a safe and effective ventilation system. If you are unsure about any aspect of ventilation design or installation, seek advice from a qualified expert. A qualified expert can provide valuable guidance and help you to avoid costly mistakes. It is always better to err on the side of caution when it comes to electrical safety. By following these guidelines, you can help to ensure that the ventilation slots in your electrical equipment control boxes are designed and installed safely and effectively. Proper ventilation is essential for preventing overheating, protecting personnel, and ensuring the reliable operation of electrical equipment.